Okay, here's your overview for the C4 topic, lesson 11, electrolysis. Right then, electrolysis is simply the process that we can use to separate an ionic compound. So let's have a quick look at what an ionic compound is. Ionic compounds are made from metals and non-metals that are chemically combined together. When they're chemically combined together, they form this regular repeating pattern of positive ions and negative ions, positive, negative, and so on. And this is in a three-dimensional format. And we call this a giant ionic lattice. The ions are in fixed positions, which means they can't move. And they're fixed because they're held together by electrostatic forces. These electrostatic forces will form an ionic bond. And this is why we have something called an ionic compound. The metals tend to be positive ions and the non-metals are the negative ions. We'd like to separate them. We'd like to get the metals free from the non-metals so we can use these to perform any other chemical reactions or make new substances or products. There's lots of different uses, but they're no good joined together at the moment. So how do we get the ions to move? Well, if the ions are fixed, we need them to move in order to separate them. So the way we do that is we can either heat them up, so we can make it molten, turn the solid into a liquid, or depending on the substance, we could dissolve it as well, more to follow in another lesson. Once we've done that, we can then separate them. Now the ions are not in a fixed position, but we've got a liquid version of these of the ionic compound, and we can now get them to move around and much more. The trick is, how do we separate them so all the positives are together and all the negatives are together? Well, this is where the process of electrolysis comes in. Electrolysis simply means setting up your liquid inside a container. So this represents our liquid, all of this area here. And there's a name for this called the electrolyte. So the electrolyte is the molten ionic compound, or dissolved. The ions are free to move around. And what happens is, we put in two electrodes. These are usually made from carbon. They could be made from platinum, anything that's unreactive, and therefore we call them an inert electrode. Inert means unreactive. We connect these two electrodes to an electrical supply, and we use a direct current in our electrical supply. And what a direct current does is it forces the electrons from one electrode round to the other, and they do move in this direction, from the positive electrode round through to the negative electrode. There's a name for the two electrodes. The positive one is called the anode, and the negative one is called the cathode, and you'll need to remember which one is which. There is a little trick you can use here. The anode, if you look at the shape of the letter A, that is the top of an arrowhead. I've drawn a little line here to turn it into an arrow. That tells you that we move upwards in this direction. So the anode goes up, then we go across, so the cathode has to go down. There's another little clever way to remember anode and positive. Anode and positive begins with letter A. The word add in mathematics or addition begins with the letter A. Therefore, positive, add, anode. That's your connecting word between the two. And if you remember that anode is positive, well, the cathode has to be negative. So what happens is when we flick the switch, this electrode becomes positive, this becomes negative, and it causes all of these negative ions to be attracted to the positive side, and all of the positive ions get attracted to the negative side. And that's the basics of electrolysis. It's really simple, nice, easy process. So we're going to have a look now at one example of that. We're going to have a look at the electrolysis of something called lead bromide. So lead bromide has the formula PbBr2, which means it's made of one lead ion, which has got a 2+ charge. We've got one bromide ion, which is negative, and another bromide ion, which is negative. And we need two of these to become negative by 2 to cancel out the positive charge over here, because our ionic compound has a neutral charge overall. Once we've got our lead bromide, we need to turn it into an electrolyte. So we're going to heat it up, and we're going to heat it up and put it into our container, which looks like this. Now it looks a bit messy inside here, but I'll talk you through it step by step. We've got two bromide ions, here they are, and we've got our lead ion as well. Here it is. I've only joined these two in this one as an example. When we flick the switch on our electrical supply, we've got our anode and our cathode. The bromide ions, because they're negative, get attracted to the positive electrode, and our positive ion gets attracted to the negative electrode. Now, two different things happen when they arrive. For the bromides, when they arrive, the extra electrons that they've got get dropped off. So these two bromide ions are now bromine atoms. And as a result then, we have lost these two electrons. If you lose electrons, according to oil rig, oxidation is loss, reduction is gain. If you lose these two electrons, we have done oxidation. These electrons actually go physically into the electrodes and can then pass around the circuit to the other side. At the same time, on the other side of the container, we've got our lead ion that arrives at the cathode. It collects electrons, so it's going to gain electrons, so we have reduction happening here. And as a result then, the lead ions turn into lead atoms. The lead atoms then build up, and we get lead forming at the bottom of the container. So you get actual solid lead metal. Back on the other side, the bromine atoms don't like to be atoms. They react together to form bromine gas, which is Br2. So you'll start to see some bubbling happening here at the same time. So here's an example of using what we call a binary compound, which means it's made of only two different types of atoms. We basically melt it, place in your two electrodes, turn the switch on. The bromide ions turn into bromine atoms, and that happens at the anode and will turn into a gas. And then finally, at the negative electrode, our cathode, we get lead ions turning into lead atoms and forming lead metal. And that's your overview of electrolysis.